Welcome to Anatomy Visions. Today, we will explore the fascinating and complex scientific journey of alcohol inside the human body. Have you ever wondered what exactly happens from the moment you take a sip until the dreaded hangover hits tomorrow? We will follow a single drop of alcohol as it travels through your organs, revealing the hidden biological processes inside. This is not just about getting drunk. It is a profound look into how our anatomy reacts to foreign substances. The journey begins the moment a glowing amber liquid touches your lips, initiating a cascade of powerful internal chemical reactions. Inside the oral cavity, a very tiny fraction of the alcohol is immediately absorbed directly through the delicate mucous membranes. As you swallow, the liquid quickly travels down the esophagus, a muscular tube connecting your throat directly to the stomach. The esophagus uses rhythmic muscle contractions to push the alcohol downward, ensuring it reaches the stomach in mere seconds today. Now, inside the stomach, the environment changes dramatically. Here, approximately 10 to 15% of the alcohol enters the bloodstream. The stomach lining acts as a highly permeable barrier, allowing ethanol molecules to slip through and enter your blood vessels. However, the stomach has a crucial gatekeeper known as the pyloric sphincter, which controls the passage into the small intestine. This muscular valve decides how fast the remaining alcohol moves forward, heavily depending on whether your stomach is currently full. If you drink on an empty stomach, the pyloric sphincter remains open, allowing alcohol to rush directly into the intestine. But if you have eaten a heavy meal, the sphincter closes tightly, significantly slowing down the alcohol absorption process today. This is exactly why drinking on an empty stomach makes you feel intoxicated much faster than drinking after a meal. The food physically blocks the alcohol, forcing it to stay in the stomach longer and delaying its inevitable systemic absorption. Eventually, the gatekeeper relaxes, and the alcohol floods into the small intestine, which is the primary site of nutrient absorption. The small intestine features an incredibly massive surface area, perfectly designed to absorb almost everything that passes through its walls. Here, the vast majority of the remaining alcohol is rapidly absorbed into the bloodstream through the complex intestinal mesentery system. The mesentery is a highly vascular network that acts as a superhighway, transporting the absorbed alcohol directly toward the liver. As ethanol enters the blood, it travels rapidly through the circulatory system, touching nearly every single cell in your body. The blood acts as a fast delivery network, distributing the intoxicating molecules to various major organs within a few minutes. Next, the alcohol arrives at the liver, which acts as the primary detoxification center and the hardest working internal organ. The liver recognizes ethanol as a toxic substance and immediately begins the arduous process of breaking it down for elimination. Specialized liver enzymes attack the ethanol molecules, initiating a chemical conversion that attempts to neutralize the threat to your body. First, an enzyme converts the ethanol into a highly toxic compound called acetaldehyde, which is actually worse than alcohol itself. Acetaldehyde is a dangerous chemical responsible for much of the cellular damage and severe discomfort associated with heavy alcohol consumption. Fortunately, another liver enzyme quickly steps in to transform this toxic acetaldehyde into a harmless substance known as acetate today. The acetate is then safely broken down into water and carbon dioxide, which your body can easily expel without harm. However, the liver can only process a small amount of alcohol per hour, usually about one standard drink every hour. When you consume alcohol faster than your liver can process it, the excess ethanol continues to circulate in your bloodstream. This circulating alcohol travels to the lungs, where a fascinating physiological exchange occurs deep within the tiny alveolar air sacs. Because alcohol is highly volatile, it easily evaporates from the blood surrounding the alveoli and mixes with your exhaled breath. This is the exact scientific principle behind breathalyzer tests used by law enforcement to measure your blood alcohol concentration levels. Every time you exhale, a tiny fraction of the unprocessed alcohol escapes your body invisibly through your warm human breath. Meanwhile, the circulating alcohol also reaches the brain, easily crossing the protective barrier with absolute ease due to its structure. Inside the brain, alcohol begins to heavily interfere with the delicate balance of essential chemical messengers, called neurotransmitters, right away. It significantly enhances the effects of GABA, an inhibitory neurotransmitter, which slows down brain activity and makes you feel relaxed. At the very same time, alcohol suppresses glutamate, an excitatory neurotransmitter, further slowing your reaction times and dulling your senses. This dual action creates a profound sedative effect, heavily impairing your motor coordination, physical balance, and ability to think clearly. Alcohol also triggers a massive release of dopamine in the central reward center, creating a temporary feeling of intense euphoria. This dopamine surge is exactly what makes drinking feel so pleasurable initially, encouraging people to consume even more alcoholic beverages. However, as intoxication deepens, the frontal lobe is heavily affected, leading to significantly lowered inhibitions and extremely poor decision-making. You might say or do things you would normally avoid, as your logical filtering system is temporarily shut down completely. The cerebellum, responsible for movement and balance, also suffers, causing the classic stumbling walk and slurred speech of a drunk. While your brain struggles, your kidneys are also working overtime. Alcohol severely disrupts the normal regulation of your bodily fluids. It inhibits the production of the antidiuretic hormone, known as ADH, which normally tells your kidneys to retain essential water. Without this crucial hormone, your kidneys fail to reabsorb water, dumping it straight into your bladder at an alarming rate. This is why you have to visit the restroom so frequently when drinking, leading to rapid and severe systemic dehydration. For every standard drink you consume, your body can expel up to 4 times as much liquid through excess urine. This severe dehydration shrinks your brain slightly, pulling on the sensitive membranes, connecting it to your skull, causing intense pain. Have you ever noticed that alcohol affects people differently today? Gender plays a very significant role in experiencing intoxication levels. Women typically become intoxicated much faster than men, even when consuming the exact same amount of alcohol in one sitting. This happens because women generally have a higher percentage of body fat and a significantly lower overall blood volume today. Alcohol does not absorb well into fat tissue, meaning it remains highly concentrated in the blood for a longer time. Additionally, women produce less of the stomach enzyme that breaks down alcohol, allowing more ethanol into their bloodstream very quickly. As the night ends and you finally go to sleep, your body is still desperately fighting the toxic alcoholic invasion. The alcohol disrupts your sleep cycles, preventing you from reaching the deep, restorative sleep that your tired brain desperately needs. When you wake up the next morning, you are greeted by the dreadful consequences of the intense internal chemical battle. The hangover is a complex physiological response, primarily caused by severe dehydration and the lingering presence of that toxic acetaldehyde. Your pounding headache, extreme nausea, and intense fatigue are direct results of your immune system reacting to this severe poisoning. Your body is desperately begging for hydration and essential nutrients to repair the widespread cellular damage caused by the alcohol. It takes many hours for your liver to finally clear out all the toxins and restore your natural biological balance. Understanding this incredible anatomical journey helps us truly appreciate the immense stress we put our resilient biological systems through sometimes. The human body is a miraculous machine, constantly working to protect us from the harmful substances we choose to consume. Next time you raise a glass, remember the complex and arduous journey that single sip will take through your organs. Thank you for watching Anatomy Visions today. Stay curious, drink responsibly, and always respect the incredible science of your body.